Welcome dear students and friends to this channel. So I Gaurav Sharma. Today we are going to start divide and conquer strategy of design and analysis of algorithm. So this is the very new algorithm design technique which we used in our day-to-day life and real world problems. So those problems which are not solvable with any traditional techniques or traditional algorithms, so we can solve those problems easily with the use of divide and conquer technique. So there are other lot many techniques are also available like greedy approaches and dynamic programming. So we will see those parts in later on classes. So today I am going to introduce divide and conquer and specifically one application of that deck, that is power of an element. So let's have a look. So this is divide and conquer. So in divide and conquer strategy, there are three steps involved. So the very first one is divide the given problem into smaller subproblems. So the very first part is division of the given problem into smaller subproblems. Now the next one is conquer. So what is conquer meaning here? Conquer the subproblems to get solution recursively. So here this is the important part, that is recursion is there. Okay, and if the subproblem is small, then return solution directly. So don't worry, I will explain recursion. And if you remember in my data structure lecture, applications of stack, so I already covered recursion and its type in detail. So those who want to learn the same, they can refer my previous videos of data structure. Okay, so this is the conquer part. So conquer means conquer the sub problem to get solution recursively, and if problems sub problem is small, then return solution directly. And the third step is what? Combine. So combine the sub problem solutions to get the original problem solution. So what we are doing here is a bigger problem. So we are having a bigger problem and we are breaking down into sub problems, okay, and solving those sub problems what? Recursively. And after solving those sub problems, ultimately what we are doing, we are combining solutions of that sub problems to get what? Final solution. So this is our approach in divide and conquer technique. So divide, conquer, and lastly combine. So what is recursion in that? So recursion means some sort of function calling to itself. So I will explain, don't worry, what is recursion. So in recursion, let us suppose this is a recursive program. So I am writing like recursion only. Okay, let us suppose this sum a comma n. And what is there in recursion? There are two things in recursion. The very first thing is called as initial condition, or it is also called as termination condition. And the second step that is involved is called as recursive steps. Okay, recursive step, and finally conclusions. So in recursive step, what will happen? So in recursive step, this function itself called itself, है ना? So the same function is calling again and again, but with different argument. Let us suppose a comma n by 2. Okay, so here are few important point which we need to remember. Say for example here termination condition, if n double equals to 1, then some sort of return. So this is our initial condition, and recursive step is what? A equals to recursive of a comma n by 2. तो हमें यहाँ पे क्या करना है? फर्स्ट ऑफ ऑल कि इनिशियल कंडीशन को चेक करना है. अगर यहाँ इनिशियल कंडीशन हम मेंशन नहीं करेंगे, देन we will go into what? Infinite loop. If unavailable, then infinite loop. If not written, if this part is not written, then we will go to then we will go to infinite loop. Okay, why? Because the function will call again and again itself without being checked that whether the condition is satisfied for termination or not. So this is the main strategy. Ultimately in recursion there are two or we can say three steps which are very must or essential. So the very first one is termination condition or initial condition, because if the termination condition is not available at the initial point, that's why it is initial, then the program or then the entire task is going to be in infinite loop. And after that there is some recursive step is also there, and also there is an change in argument there. This is also important. Okay, so change in argument. Okay, so there is change in argument each time, every time. Okay, otherwise that will call same again and again. Okay, so this is the simple recursion. And if you want to go into depth, then refer my previous lecture that is related to recursion and its type, so that I have already covered in data structure. Okay, now this is the control abstraction of divide and conquer strategy. Control abstraction means we are just showing that how the flow is going to work. Okay, so let us assume this is DAC, divide and conquer, and P and Q are let us assume two arguments are there. Okay, and this is the starting of this and this is the closing of this. This is what initial condition. Initial condition is that if the problem is small enough, so simply return the solution. So this is the returning of solution. Else, so this is recursive part. So else we are calling the divide. So this part is what? This part is recursive step. Recursive step. Okay, so in that what we are doing, that dividing the problem first of all, and assuming that m is the division part, and again calling that particular divide problem, and finally after returning we are combining. So combining में inside we are calling deck, that is deck means calling it again, and deck again here with some different argument. तो यहाँ दो पार्ट में हमने कॉल किया है सेम. So this is not recursive step, basically this is recursive step. So this part as well as this part is recursive step. Okay, and this is what? This is division step. Okay, and finally after coming from the solution part, we are finally combining it. So this is the combining and finally return. So just control abstraction, just showing how the things are going on. Okay, so in the above program, flow of control is clear, but definitions of major functions are not given. That's why it is called as what? Control abstraction in divide and conquer strategy. So I hope that this is clear. Now let us move to some different things related to that deck in actual implementation part, so that you will be comfortable in that. So in that what we are doing, this is T of n is, let us suppose time required to solve what? The problem with size n. Okay, so if the problem is small enough, then it is taking g of n time. G of n means maybe some constant time. Okay, and if the problem is big, so just come to this part and break the problem into n by 2 and n by 2, two halves. And let us suppose this, for n problem, time taken is what? T of n. So for this particular, time taken is what? T of n by 2, and for this half, time taken is what? T of n by 2. And finally this c is what? The c is finally combined in this part. So how we can write this? So this we can simply write it as T of n equals to recurrence relation. This is the recurrence relation. So how we are solving that? G of n, it is a constant time. Okay, if small, अगर small है तो simply constant time लगेगा. Otherwise what we are doing, T of n by 2 time it is taking, plus T of n by 2 time it is taking, or plus some sort of functions, let us suppose f of n. Okay, this is the case when what? If big. Okay, if problem is big. So this we can also write it as 2 times T of n by 2, and plus this is f of n. So this is some function, maybe the time taken by in the division process or combining process. So this is the same. Okay, so this 2 is number of subproblems, and this fn is what? Time taken in divide or combine or what, both, whatever may be the case. So this is the general structure of the divide and conquer strategy. So this may be the case that let us suppose the problem is not we are dividing the problem into what, some exact amount of part, that is n by 2 n by 2, some different partitions are there. Let us suppose n1 n2 n3 n4, and this is, and if this is small enough, then move to this part, and otherwise if the problem is big, then just divide it. So let us suppose the time taken is, in this term, is simply like this, that it is g of n, in case of if n is what, n is small, if n is going to be small, if n is small, or otherwise let us suppose t of n1, time taken to solve n1 size problem, plus t of n2 plus t of n3, and plus so on, so up to last t of nk. So this is the case if n is what, n is big. Okay, and plus some, let us suppose some function f of n. Okay, so this is the case. So this is the general structure. Maybe uniform division is possible, or non-uniform division is also possible. Okay, so there are some applications related to a divide and conquer strategy. So like finding maximum and minimum, power of an element, binary search. So don't worry, I will explain each and every uh, point or each and every problem in detail in the upcoming lectures. And merge sort, quick sort, selection procedure, and Stresson's matrix multiplication. So in this lecture, we are going to cover power of an element and see how this power of an element is a divide and conquer strategy. Why it is better approach if we are solving, if we are calculating power of an element with the help of divide and conquer strategy. So this is the power of an element. So what is given there? Here input is given that a, an element a is greater than 1, and an integer n which is what, greater than 0. So say for example a is going to be your 5 and n is going to be your 2. So what will be the output in that case? So this is our required input, let us suppose. So what will be the output in this case? So it is a raised to the power n, means let us suppose 5 raised to the power 2. Okay, so finally this will result as 25 is the answer. Okay, so ultimately what power of an element is nothing but the repetitive multiplication. Okay, so let us suppose if you want to calculate 5 raised to power 2, so what we are doing, 5 multiplied by 5, so this will give me the required solution as 25. So repetitive multiplication. But now let us see how the designing algorithm designing approaches will differ in time complexity. Okay, so very first is without divide and conquer. So what is without divide and conquer? Just calculate power of a comma n. So these are two arguments, a and n. So a raised to the power n we are supposed to calculate, and we are taking here an integer f equal to 1, and this is I. Okay, an integer I. So for I equal to 1 to n, because हमें n तक जाना है. For example, a की value क्या है? A is going to be 5 in our case, and n is going to be 2. So हमें n तक move करना है. I starts from 1. So this is simple of for loop. Repetitive multiplication है. So f equals to f into a. So what will happen in this case? That finally after completing, what will f hold? F will holds what? 5 into 5. That is what, 25. And finally after coming out to the loop, we are printing the f. So what will be printed? So here 25 will be printed. So now observe very carefully that let us suppose if the n size is very large. Okay, take an arbitrary number n. So n size is very large, so this loop is, this statement is running n times from 1 to n. So ultimately the overall time required to solve this problem, time complexity. Time complexity. So what will be the time complexity? So the time complexity for this is what, order of n. Okay, why it is order of n? Because n time the loop is running, each and every time it is multiplying by itself, है ना? And storing the same number. So this is order of n. So we can say that best case is also order of n, because ultimately n time it will run. Worst case is also. So we can say that it can be represented as theta of. Okay, so this is without divide and conquer approach. Now we will see कि अगर हम इसको solve करेंगे with divide and conquer approach तो क्या effect आएगा time complexity में. Okay, what will be the resultant time complexity if we solve this particular problem with the use of divide and conquer strategy. So let us see this with the use of divide and conquer. So this is using divide and conquer. So what is the approach here? So the approach is that for example we are solving a raised to the power n. So what we are doing in that, so just solve a raised to the power n by 2 for half. Okay, and multiply it with itself. So a raised to the power n by 2. So you will get the final result. Okay, let us suppose for example if you want to calculate 5 raised to the power 4. So how to do this? Just solve 5 raised to the power 2, just half of that. Okay, and whatever will be the result, so the result is multiplied with itself. So the result is multiplied with itself is 5 raised to the power 2. So ultimately you will get the same answer. Okay, so this is the divide and conquer strategy for power of an element. So how to solve this? So we are taking integer f for storing some value, and this is the initial condition over here. This is the initial condition. Initial condition. Every divide and conquer algorithm or program is always what? Recursive in nature. There is always a recursion. So whenever recursion is there, there is always a need of what? Initial condition or termination condition at the very beginning. Okay. So n equals to 1. So return simply a, because for example 2 raised to the power 1, so simply return 2 only, hai na? Or say for example 5 raised to the power 1, so simply return 5 only. So in this case nothing is there to calculate. Okay, so this is the termination condition, simply return a. Else otherwise what will happen in this case? That power of an element will be calculated as a comma n by 2. So again this is what? Recursive step. So this is the recursive step. This is the recursive step. So what we are doing in recursive step, a comma n by 2, again we are calling to it half, hai? And whatever the result is coming, so this is storing we are in f and multiplying f with f. Okay, and updating f only and returning finally f. So see how this algorithm will work. Let us see this. Say for example you want to calculate for example let us suppose 5 raised to the power 4. So in this case a is going to be what? 5, and n is going to be what? 4. So firstly we are calling what? Power of an element. So the function name is pow 5 comma 4. So n is not equals to 1. So else part, what is else part? Else part is going to be f equal to power of n, power of a comma n by 2. So what is n by 2? 4 by 2 is going to be 2, and here two more steps are required. Okay, now come to this. So if you are coming to this, so again n is not equal to 1. So simply f equals to what? Power of uh, a is what? 5, or n by 2. 2 by 2 is going to be 1. So here two steps are pending, still pending. So now come to this part. So recursive call is going on. So this is calling to this and this is calling to this. So this initial condition, if n double equal to 1, so return what? Return a. So return what? 5. So this will return 5. Now let us see what will happen in this case. So here we are returning 5. So this 5 is returning. So ultimately this entire result is what? This 5 is going to be returned. So the entire result is 5. And here is what? F equals to f into f. So 5 into 5 is 25. And here we are returning 25. So 25 will be returned. So this entire thing will be what? This entire thing will be called as 25. Okay, now here two steps are involved, f into f. So 25 into 25, which is going to be 625, and returning of f. So return 625. So return 625. So finally the result of this particular thing is what? 625. Okay, as we are very much aware that 5 raised to the power 4 is going to be 625 in our case. Okay, so this is by using divide and conquer. Now let us analyze the complexity of this algorithm, how this algorithm, maybe it is better or not better as compared to the without divide and conquer strategy. So let us see. So firstly, t of n equals to time taken to solve with n, and number of problems means n is the size, है ना? Or in our case, what is n? N is this which we are calculating, power, है ना? So highest power n. So if n equals to 1, so this is the case. If n equals to 1, so simply return a. Return a means simply just constant time. So we are writing it as 0 or either some c or some 1, whatever, and you wish you can write it as. So it is I'm just writing is 0 means 0 time is required, nothing else. Otherwise, so this is the if n equal to 1, n is greater than 1. So what n is greater than 1? So solving the problem in n by 2 terms. So n by 2, and again some multiplication and returning steps to some constant time. So t of n by 2 and plus this is for multiplication. Now you are very much aware that how to solve this kind of recurrence relation. So for solving recurrence relation, there are three strategies. So what are those strategies? So first method is what? Substitution method. Substitution method. Next one is recursive tree method. Recursive tree. And next one is what? Master's method or master's theorem. Master's theorem. Okay, so in this case you may apply anyone, है ना? So let us solve this by substitution method. So what is the strategy? T of n by 2. तो t of n by 2 को अगर आप यहाँ replace करेंगे, so what will be the answer? This is like this, plus 1 is as it is t of n by 2. So if you place in place of n by 2, so this will give you t of n by 2 means n by 4 and plus 1 already, and there and this. So this will result in t of n by 2 square, and this plus 1 and plus 1 is going to be 2. Again one more step. So if you again put it in terms of n by 4 or n by 2 square, so this will result n by 8. N by 8 means n by 2 raised to the power 3 plus 1 and plus 2. So plus 1 and plus 2 means plus 3. So repeat this for k times. Let us suppose k times. So this will result as a t of n upon 2 raised to the power k, and here see, here it is 2 raised to the power 1, so it is 1. Here 2 raised to the power 2, it is 2. We are repeating k times, so n upon 2 raised to the power k, so it will be k. Okay, so now observe very carefully. So at last this problem is going to be what? This n upon 2 raised to the power k is going to be 1. Okay, because this problem is going to be 1. So in case of n equal to 1, this will be 0. So like this. So from here we will get n equals to 2 raised to the power k and k equals to log n base 2. So we are getting the value of k as log n base 2. So finally substituting over here, so t of what? 1 and plus t of 1 and plus this k is what? K is what? It is log base 2, and t of 1 is going to be what? N equal to 1 पे value क्या है? recursion 0 and plus log of n. So finally what is the major step? Major step is what? Log of n. So the time complexity here, so time complexity to calculate power of an element using divide and conquer strategy is going to be order of log n. So it is very much evident that this approach is what? Quite efficient as compared to the previous one, that is solving power of an element without divide and conquer takes order of n time, whereas solving power of an element with divide and conquer approach takes order of log n time. So this you know very well that log n time is quite what? Lower as compared to linear, that is order of. So this is better algorithm as compared to. Okay, so I hope that this concept is clear to you. So this is the introductory part to divide and conquer technique. And if you are having any doubt, so you are welcome. Please write in comment box section of this particular video. है ना? Happy learning to all of you. Stay safe.